Before learning how to balance chemical equations, one should recognize why it's necessary. Since the atoms or ions of reactants rearrange, they must be equal in number on both the reactant and the product sides of a chemical equation. When looking at this chemical equation, you can see that there are 2 atoms of hydrogen on the reactant side, as well as 2 atoms of hydrogen on the product side. Recall that the reaction arrow separates the reactants from the products of a chemical equation. Therefore, the hydrogen atoms of this chemical equation are already balanced. However, when looking at the oxygen atoms, you can see there are 2 atoms of oxygen on the reactant side, but only 1 atom of oxygen on the product side. Therefore, the oxygen atoms are not balanced in this chemical reaction. To balance a chemical equation, you must first recognize which atoms or ions are common to the reactant and product sides of the equation. In this chemical reaction, hydrogen is common to both the reactant and the product sides, as well as oxygen. Looking at the reactant side, you can see that there are 2 atoms of hydrogen on the reactant side. While looking at the product side, you can also see that there are 2 atoms of hydrogen on the product side. Again, that means hydrogen is balanced. However, when looking at the reactant called oxygen, there would be 2 atoms of oxygen on the reactant side, yet only 1 atom of oxygen on the product side. This indicates this reaction is not balanced for oxygen atoms. In order to balance, you can only write coefficients, which are numbers that are written in front of any reactant or product in an equation. The coefficient multiplies the amounts of every atom or ion that it is written in front of. Since there is only 1 atom of oxygen on the product side, a coefficient of 2 would multiply that amount to double it. By writing a coefficient of 2 in front of water, this doubles the amount of oxygen that is present on the product side. Now there would be 2 atoms of oxygen present on both the reactant and product sides. However, this 2 also doubles the amount of product for hydrogen. Therefore, on the product side, there would now no longer be 2 atoms of hydrogen, but there would be 4 atoms of hydrogen. With only 2 atoms of hydrogen on the reactant side, we now need a coefficient to make those amounts equal on both the reactant and product sides. A coefficient of 2 written in front of hydrogen on the reactant side doubles the amount of hydrogen atoms present and creates the 4 that we would need to balance for both the reactant and product sides. This creates coefficients of 2 for hydrogen, 1 for oxygen, and 2 for water. Therefore, the balanced equation has these ratios of reactants to products. Recognize that whenever a coefficient is not written in front of a reactant or product, it represents the value of 1. Let's now look at the B example. The atoms present on each side of the reaction would be the iron and oxygen atoms. You can see on the reactant side there is only 1 atom of iron, yet on the product side there are 2. Looking at the reactant side, there would be 2 atoms of oxygen, but looking at the product side, there would be 3 atoms of oxygen. Therefore, neither iron nor oxygen are balanced for this equation. If starting with the oxygen, we wish to balance the equation, looking at oxygen on the reactant side, there are only 2 atoms, yet on the product side there would be 3. We're looking for a coefficient that could create the same quantity of oxygen atoms on each side of the reaction. Notice there's no coefficient that you could place on the product side that would create the quantity of 2, which is what you have on the reactant side for oxygen. Therefore, we want to think about what number the 2 oxygen on the reactant side and the 3 oxygen on the product side might meet up at first, or what is the multiple where they would meet? The number 6 first comes to mind. In order to create 6 oxygen on the reactant side, a coefficient of 3 must be chosen and written. This creates 6 atoms of oxygen on the reactant side. In order to get 6 atoms of oxygen on the product side, we would need to choose a coefficient of 2. 2 times 3 creates the 6 oxygen that we would need. The chemical equation is now balanced for oxygen. However, you'll notice the amount of iron has now been doubled for the product side. This makes a total of 4 iron on the product side, yet only 1 iron on the reactant side. Therefore, a coefficient will be needed for iron on the reactant side. The coefficient of 4 would create the 4 iron atoms needed to balance the equation. Therefore, the coefficients necessary to balance the equation would require 4 iron, 3 oxygen, and 2 iron 2 oxide, iron 3 oxide.